Hey guys, Lucas here and welcome to Coding with K. Have you heard of GitHub? You probably have, but do you know what a Git actually is and how to use it? If not, I got you covered. If you do, maybe you can just judge my code or discuss which platform you like best. But what is it? What is Git? Well, first of all, Git is a command you type into the console window, duh. Jokes aside, to understand Git you better first know the problem it solves. So let's code a little piece of software to showcase it. Yes, Git is for code, mostly. In principle, any kind of text really. You can even use it for writing a novel or video script. How about a journal? Let's now create a new file with our favorite text editor, NeoVim. That's of course what real hackers use. For this example, I want to write a function in the programming language Rust. This function is meant to calculate the factorial of a number. And just by the way, the symbol for the factorial in math is the exclamation mark. 5 factorial equals 1 times 2 times 3 times 4 times 5, and that's of course 120. Note, 0 factorial is 1 and it is not defined at all for negative numbers. That's an actual mathematical expression in case you didn't know it. However, the programming languages I know don't have an operator for it like multiplication. It's usually some kind of function. So let's code one ourselves. Function factor, which takes an input value of x as 64-bit integer. And it returns some solution which is the same type. Let's just keep this simple for now as a placeholder. As we've learned, the factorial can't be smaller than 1, so that's where I start. Rust, like most languages, also requires a main function for the program to run. So let's add that too. No inputs, no outputs, straight and simple. And this prints the solution for 5 factorial out on the screen. In this case, the console window. Let's just give it a try. Now, in case you are confused by the console, this is just a text version of your regular file explorer. As you can see, there is one file in the folder, our app.rs. In order to list the files in the console, I simply use the command ls for list. I can also use my file manager, Ranger. On Windows, I recommend Yazi. Next up, let's verify whether the Rust compiler is installed correctly. rustc --version. Alright, now rustc app.rs. I hand my code file over to the Rust compiler and it turns it into a binary file. It complains a bit because I don't use my input variable x just yet, but that's okay.
Let it complain.
I'm on the Windows subsystem for Linux, by the way, so it's not a .exe file, just in case you wonder. If you do this on Windows, it'll be an executable. And I can run this little program like so, /app. Okay, that works, but let's make our code a little bit more readable. Let x equals 5 and change the print line. Okay, compile and run it again. Not perfect, but much better. Now this shall be the first version of the program. Before I go on, I'll create a new folder, vo.1, and back up my file into it. This seems efficient now that our program is small, but imagine we'd be working on a game hundreds of megabytes in size. This sort of backup and version tracking system consumes huge amounts of space and is difficult to read. You need a lot of documentation to make sense of it, like where did you change what, etc. Now of course, there is a smarter way, and the smarter way is Git. What Git does is to start an initial state and then only save the changes to it. It's a little like recording your brush strokes for a painting. You can go back to a previous state by reversing brush strokes anytime. But first things first, let's create a new Git for our project. Like with Python, let's first verify Git is installed correctly. Git --version. Okay. And now git init for initialization. That has now created a hidden folder .git. Let's check it out. Okay, It's full of stuff we don't have to worry about. We will never actually touch this folder. That's of course why it's hidden. However, it's good to know it's there. If you delete that folder, all your tracking is gone for good. So what now? Git good. Haha. There are a handful of Git commands you have to know in order to make proper use of it. All commands can be found using git --help. And for every command, git --help command name. That opens the lengthy manual. It's a lot, but again, you only need a handful of commands to get started. So let's start. Git status. That tells us whether there is something to do or not. In this case, we have a file Git has found and it wants us to add it. So let's do that. Git add followed by the file name. Git will now keep track of the changes in that file for us. If we want Git to ignore specific files, we can create a .gitignore file. Let's do that too, so that Git won't complain about the binary file we create later, which of course is not a text file and which we don't want to track. And git status again. Okay, now it wants us to commit the changes. We have added a file. So git commit. This now looks a little confusing. What Git did was to launch your favorite text editor, in my case Deovim, and it wants me to type a short comment for the first commit. I'll just type something descriptive. Start project, edit first file. These commit comments can be as long as you want, whatever floats your boat. Now there is no rule how often you should commit to changes, but to keep things tidy, you shouldn't commit like every few minutes. Rather, commit when you have developed and finished a new function, for example, or written a new scene or chapter of a book. Git just tracks your progress and is not a database you have to update every time you turn the PC off. And another unwritten rule is to only commit code that works. Like, don't commit stuff that has errors in it. Unless of course you work with somebody else and want them to fix it. Anyways, let's go on. Now that we have our first commit, we can check the log. There you see our comment, and this one here is the commit hash. It's a unique ID for this particular commit. And you see my name. Wait a second, I forgot. If you're using Git for the first time, you will run into an issue because you have no name yet. So in order to change that, we can define a name for this project. Or like I do globally using the --global option. Git config --global user.name and Lucas. I repeat the same for the email where I just use my handle. Now the commit should work. And git log, swell. I don't know about you, but I want to finally implement the function and not just mess with Git. So let's finish it. All I do is to multiply all values from 2 to x to my solution using a simple for loop. That's all it is. One thing I forgot to mention is that in Rust, the last value inside of a function is returned by the function. So you often don't need the return command like in other languages. But okay, let's check if that runs on the first try. Sort of. We get no error, but the solution is wrong. What a surprise. The correct solution is 120. And the reason is just a quirk of how this double dot operator works. It does not include the final value x. That has to do with arrays. An array with 10 items is indexed from 0 to 9. So you'd go from 0 to number of items, which would be 10, without going over the boundary. However, Rust has us covered. I simply have to add an equals sign to include the x. Okay, so we have made a meaningful change to our project and it runs. Time to commit. Let's do a git status for good measure. As you can see, it asks us again to add the file to the Git. Now, this is because in theory you can change multiple files, but only commit changes you've done in one. So it wants to know which changes you want to commit. In our case, we commit all, so we can simply type git commit -a. That's it. The changes were committed. we can view the log again and have a nice overview about what we've done. This is what Git is and how you use it. Now, an online platform like GitHub is where you can share your Git with others to collaborate or to learn from you, but that's not necessary. Git works 100% offline too. Okay, that's it for this video. Auf Wiedersehen and wait, one more thing. You can end the video here, but I wanted to show one more trick using Git, and that trick is branching. Oftentimes in development you will find yourself working on different features at the same time, or different chapters of a book, especially when collaborating with others. Git branch will display all the branches. We currently only have one, of course, which is called master. So let's change that. However, let's not branch off from where we are, but where we were. Git log to check for our hash again, and let's grab it, copy and paste. Git branch smart hash code. And now git switch to smart. Check branch again. Now we are in the new branch called smart. And let's check our file. Boom, our file is back to start. What? Yes, Git has full control over our files now, and with great power comes great responsibility. Just so that you know, you can completely ruin your project with the wrong commands. So I would experiment with a project that's not so important first, like a YouTube video. Let's now implement our function in a smarter way. Turns out a for loop is not it. I want to solve it recursively, using a recursion. What that means is we call our function inside the function itself. Now that can really hurt in the brain if you have never heard about it, but doing this creates some kind of virtual construct that would normally crash the program. It's an infinite loop into itself. You call the function, it calls itself, and then again and again and again. It would multiply 5 times 4 times 3 times 1 times 0 times -1 times -2 and so on. So what we need is a breakpoint in the function that collapses the virtual construct. This sounds way more complicated than it actually is though. All we have to do is to add a condition. Only do this recursion when x is bigger than 1. Otherwise, return 1. Since we want to return a value from inside this if statement, we have to add the return like in most other languages. That's it. As long as x is larger than 1, the function will continue calling itself with a smaller value. Once we reach 1, it'll return 1, an actual value that the recursion collapses from the back to the front. You can solve most problems recursively. While it is extremely satisfying, it's not always the fastest way in terms of computing efficiency. But it's still a fun challenge nonetheless. Let's try it out. Looks exactly the same from the outside, but better from the inside. Our program gained character. Anyways, we've yet again done a meaningful change, so time for a commit. Let's not forget a useful comment. And now we have multiple branches we can hop between and observe the code changing. I still remember the first time I learned about it. It was epic. Switch master, switch smart, switch master, switch smart. Now we can do something you normally should avoid. We can merge smart into master because the master solution is not so great. Normally, you'd only merge branches into master that changed something about it that wasn't changed in master afterwards. So the correct way would have been to branch out before we change master twice and then merge the better branch. Because now, as you will see, there is a conflict. The same file was changed after our branch point. So Git is not sure which changes should be kept. Quick check if we are in master and git merge smart. If we now check our file, Git added the new code but left the old one. And it added these weird arrows, which make sure it doesn't work anymore. So you can't leave this untouched by accident. This can be messy, but you just have to remove the parts you don't need. But again, this wouldn't have happened had we merged new files into master or if we didn't change them. Anyways, we are now left with just the code of the smarter branch. Making sure it compiles without error, we can now commit our changes again. It even filled the merge comment for us, so all we gotta do is save it. And we're merged. Smart and master are both the same now, so we can delete the smart branch. Git branch -d smart. As mentioned, using branches is more sensible when you want to develop new features. You then merge into master once they're done. Or just backups of your project. And when you have a release version, you create a branch for that. And now in the end, as a short summary, all the Git commands we used. Just by the way, in the info box you can find this video as a PDF document. Feel free to check it out. So, git help to find help, git init initialization, git add to add new files, git log of course, git commit, git branch with a branch name, switch, merge, delete a branch, and of course config for the name and email. I put a new one in brackets. It is fairly common to revert changes done by a commit, but it is extremely dangerous. This can trash your entire Git. I'm talking out of experience. I instead create a new branch from an earlier commit and then merge. That is less destructive. I still keep the old branch. I can delete it or keep it. Now all these commands have their own options. They have more depth. And as already mentioned, you can read up on this using git help command name. Okay, that's it for this video. If you have any questions, feel free to ask them.
Macht's gut.
Auf Wiedersehen.
Au revoir.
Adios.
Sayonara.
Do widzenia.
See ya. And
thank you for watching.